Alright, your 3 CWDL water-cooled air compressor. Wabco Corporation operating maintenance manual. Instructions. Note, the following description is operated with the base on the device and its components being new, and this device components having been repaired, tested, installed, maintained in accordance with the instructions issued by this and other applicable Wabco Corporation applications. Warning, at the time of any part of this replacement of the device, the operational complete of the device must be serious with the test prescribed with the latest issue of the applicable WAP test specification. At the time the device is applied to the brake equipment arrangement, the stationary vehicle test must be made to ensure that the device functions properly in the total brake equipment arrangement. Consult your local WAPTEP Corporation representative for identifying the identity of the test specification and the latest revision date and the core of the device. Important, only WAPTEP Corporation supplied parts are to be used for the repair of the device in order to obtain satisfactory operation. Commercial available on non-OEM parts are acceptable. Note that the part numbers in there accepted the description and property of the WAPTEP Corporation might not be replicated in any other form without prior sole written consent of the officer of WAPTEP Corporation. Table of contents, preface, general description, the 3 CWL air compressor, description of major parts, components, cylinder head, valves, crankshaft, connection rods, main bearing, pump, oil level gauge, float type, oil level gauge, dipstick assembly, spin and oil filter, valve, crankcase, breather valve, operation, 3-4, designation, 3-cylinder water tool, type, compressor, 5, system, serialization, 6, general specification, 3 CWL type of compressors, 7 safety procedures and warnings, 8 cleaning solvent and lubrication, cleaning solvent lubricants, 9 parts catalog, replacement parts, part catalog, replacement parts, dual fixtures, 10 maintenance schedule, 11 maintenance procedures, on-car maintenance, removal from locomotive and component disability, 12 cleaning. 13 condemning limits, 14 repair, cylinder, piston rings, crankcase, main bearing, bend plate, main bearing, cover plate, crankshaft, cover, connection rod, oil pump, oil level gauge, flow type, main bearing, cylinder head and valve, the oil unloaded cooler, intercooler, safety valve, crankcase, breather, torque valves, assembly. Crankshaft, main bearing plates, crankcase, oil shield, introduce ring, oil seal, oil pump, cylinder piston assembly, high pressure cylinder head assembly, low pressure cylinder head assembly, side covers, intercooler, water, air, wear and test, 17 compressed capacity test, and 18 installing alignment with the compressor with diesel engine. R1, preface. The equipment of the device is covered with the publication with the manufacturer sold for the WAPTEP Corporation design and construction to perform the maintain here and proper installation period and inspection testing routine specified maintenance with all the parts within accordance with the instruction issued with any other applicable WAPTEP Corporation publication must be adhered to. WAPTEP Corporation must be used during the overall routine maintenance and ensure the proper operation of the equipment and device is not responsible for the workmanship associated with the maintenance of the device will be accepted with the work done by a repair center and not operated with the WAPTEP Corporation. Note, the following equipment description is of the equipment in operation based on the equipment of all the components, devices being new and having been repaired, tested, installed, maintained in accordance with the instruction specifications issued in the WAPTEP Corporation. Instruction. The instruction contained with the publication presented with the guide to maintenance of the repair shop and the condition following with the removal of the specific device from the locomotive. Important. The WAPTEP Corporation constantly improving the product line, researching and developing new products, changes in deciding the function of the device and air of the equipment make result of the research and development, therefore the material of the publication subject to change and without notice. 1-1. General description. 1-2. The 3 CWL air compressor. The 3 CWL is a water-cooled 2-stage 3-cylinder W configuration with single-action air compressor with a design to provide compressed air with the locomotive application. The compressor is directly driven with the locomotive diesel engine with the appropriate coupling for the drive shaft. The compressor is designed of operation with a maximum discharge with 140 psi gauge. The compressor of the stroke of the 5 inches and the section 3.0 for designation of the capacity of the weights are covered under section 6.0. Contact the WAPTEC representation WAPTEC engineering department for the additional information. 2. Description of major components. 2.1 cylinder. Reference to figure 1 and 2. The compressor has two 7.88 inches diameter low pressure cylinders in 1, 5, 7, and 5, 7, 5 and 3/4 of an inch diameter. High pressure cylinder. Both cylinders have fully jacketed cooling passage. Cylinder heads involved with reference figure 1 and 2. Each cylinder has an inlet and discharge valve with the valve assembly consists of the valve C-springs, and inner or outer valve disc. Unloaders are installed with the inlet valve so that whenever the set main reserve pressure is reached and not exceeding 140 psi gauge, the compressor will be unloaded. Note that cut-in pressure should be at least 10 to 15 psi gauge less than the cut-out pressure. The crankshaft with the connection rod reference figure 3. The crankshaft connection rods are made with a ductile iron pressurized oil pump passing through the rifle drilled holes in the crankshaft to lubricate with the connection rod and compressor main bearings. The connection rods are filled with replacing bearings insert with a wrist pin and in bushing. Our figure 1 shows the low cylinder pressure and head assembly. Alright, so you have your cylinder and your different cylinder pistons, your high pressure cylinder and head assembly. This is the head, this is the cylinder. Your crankcase, alright. Your crankshaft assembly rod here goes all the way up the crankshaft and the piston on the rod, you know. 2-4, the compressor piston reference figure 4 with low high pressure piston with the construction with an applicable ground cast iron. Each of the piston has 1 or 3 compression rings. The low pressure piston has a brass wrist pin bushing press into the pushing piston. On the high pressure piston, need of a roll bearing system. The 22.5 main bearing. The 2 taper roller bearings are utilized within the compressor. Some of the bearings are lubricated with the crankshaft oil passed through the crankshaft. The 2.6, the oil pump. Lubrication for the compressor is provided with the gear-driven oil pump. The pump is operated with a mating helical gear that connects with the oil pump in the crankcase. This shows the oil pump. Alright, 2.7, oil level float gauge. The float type of gauge provided leakage-resistant means with a measurement of the approximate level in the crankcase. The float type oil gauge consists of the ball flow with the rest on the oil supply. The vertical displacement of the float determined with the oil level in the crankcase rotates through a gear mechanism. Shaft which runs into the gauge. A permanent magnet is attached with the end gear end of the shaft. The magnet controls the point over the visible edge side of the gauge. The magnet arrangement is used to ensure that there is no physical opening from the atmosphere inside of the crankcase. 2.8, oil level gauge dipstick assembly. Dipstick type oil level gauge assembly, when properly installed, is designed to permit oil level in the compressor crankcase to be checked with the compressor running or shut down. No slippage of the lubrication oil should occur when the oil level reading is taken. The dipstick assembly consists of the spring loaded with the ball check with the push off the seat when the dipstick gauge is properly screwed in the dipstick tube to its normally fully closed position. This allows crankcase oil to reach its level with the dipstick. When the dipstick gauge is removed, it will take the oil level reading, but the ball check seat at the bottom of the tube restricting on the oil spilling when the compressor is running. The dipstick assembly is sort of designed with no surge of the oil should occur within the tube. Positive indication of the oil level is shown with the dipstick gauge even when the compressor is operating. Alright, 2.9, the spin oil filter valve reference figure 6. The spin oil filter used for the compressor with the full flow of the design built in with the pressure relief valve. The block mounted on the side of the compressor crankcase contains the valve provides the oil pressure so that the control during the idle maintains the minimum oil pressure and ensures the adequate oil pressure all compressor speeds. 2.10, crankcase breather valve. The crankcase breather valve operates with the check valve provides with a particular crankcase vacuum during the normal operation of the compressor and the discharge replaced with the crankcase during the compressor process. The breather valve consists of the body breather valve and the metallic filter. Alright, number 8 would be your spin oil filter with into its valve. Number 7 shows the crankcase breather. 2.11, the inner core safety valve. The inner core used the coil with the air between the first and second stage of the air compressor is designed using locomotive and engine cooling water, which passes through the intercooler internal stages to remove the heat and generated with the oil air being discharged from the low pressure cylinder. The drain valve is provided with the bottom of the intercooler with the drain condensate. Relief valve set at 60 psi gauge is mounted on the intercooler for the purpose of limiting pressure buildup in the intercooler. Figure 8.1 shows the A1 intercooler relief valve assembly. Alright, figure 9 shows the intercooler assembly, which is like a radiator, alright. 3. Operation. Important. To the low-pressure cylinder head with the boiler, large 3-cylinder to be fitted with the WAP-type Corporation approved with the air intake with the filters mounted with the recommended piston on the intake flange. Each lower-pressure cylinder discharged into the intercooler with a discharge of manifolds to supply the air high-pressure cylinder with the second stage compression on the downstroke with the low-pressure piston. Air passes through the air intake of the atmosphere in the chamber above the 2 inlet valve with the cylinder head. The partial vacuum created with the cylinder underneath the valve plates may be the downward stroke with the piston permits the atmospheric pressure above the inlet valve with overcoming the resistance valve with a spring seat under the valve plates and force of the valve plate from the seat and then valve in the cylinder until the pressure is above below the valve plates are about equal. The inlet valve is closed by its spring. An upward stroke the low pressure 6 piston and there airs the compressor sufficiently with the discharge valve against the resistance of both the spring and inner core pressure. The compressor there then passes through the discharge valve and into the intercooler where it cooled before the flows into the inside of the inlet side of the high pressure cylinder head. The discharge valve is closed with the respective springs with the pressure above the valve back becomes equal to the pressure underneath. The cycle operation described for each of the low pressure cylinders is operated with the high pressure cylinder, and in this way the intermediate intercooler pressure is raised with the second stage level, which is slightly greater than the main reserve pressure. The main reserve pressure is not to exceed 140 psi gauge. The compressor operates with the load until the build-up of the main with the reserve pressure increase with the cutout pressure setting with the compressor control with the switch governor, which may be supplied with the WAP-type Corporation. The setting should normally be 140 psi gauge. At this point, with the compressor control switch, the governor should be functioning with the direct air of the unloader line and the underloader line and unloaders. The requirement for the reduce the main reserve pressure is to cut in the pressure setting with the compressor control switch with the governor cycle in an age. Again, repeated with the cut-in pressure setting of the should be normally 130 psi gauge. Note the cut-in pressure should be at least 10 to 15 psi gauge less than the cut-out pressure. The air displaced in the crankcase during the compression process is discharged by the wave of the crankcase breather, which provides a partial crankcase vacuum during the normal operation. 4.0, the designation for the 3-cylinder water-cooled type compressor. To the typical WAB-type compressor is described as follows. The 3 CWL, whereas 3 total number cylinders, 3 C compound compressor, W water-cooled, D direct drive, and L large oil capacity. Alright, 5. Serialization. The 3CWL compressor is serialized according with the week and the year and the number of the compressor built in the week. According example, 050418, the compressor was built in the 5th of the week of 2004, with was the 18th compressor assembled during the 5th week of 2004. 6. General specifications. The 3 CWDL type of compressor referred to Table 2. 7. Safety procedures and warning. Regular operating property with the safety procedures must be followed with performing any work with the 3 CWL compressor. The work area should be clean. Warning. Extreme care must be taken with the handling device of the components while performing the many of the tasks associated with the repair. At utmost important for the workman read, understand, comply with the appropriate warnings listed in during the implementing this procedure. Use of the air inlet, which must be less than 30 psi for the gauge of the below parts clean, and blow the dirt air from being cleaned with the solvent cover the particular particle of the dirt and droplets clean solvent to be airborne. This condition may cause the skin and eye irritation. When using an air jet, do not direct it toward any other person. Improper use for the air jet could result in bodily injury. Proper eye protection must be worn with performing any part of the working device of the components part to avoid any serious eye injury eyes. The use of solvent clean agent for the use of the lubricating can involve the health and safety standards. Safety hazards for the manufacturer of the solvent. The lubricant should be active for the safety data with the such as OSHA form OSHA 20 is equivalent to the recommended precaution. The procedure for the manufacturer should be followed when performing any test of the work device of the equipment while they are on the vehicle. Special precautions must be taken to ensure the vehicle the movement may not occur with it, which could result in the injury of the personal or damaged equipment. Assembly may be under the spring loading. Exercise caution during the assembly to show that no parts are flying out, causing bodily injury. All air supply electrical current into the device or into any of the components must be cut off before this device or any other component part is removed from the equipment arrangement. The bolted up both at up air and pressure, even though the supply with the is cut off, the main may cause the gases and particles of dirt to become airborne, increase the sound level when the device or any of the component part and removed from the equipment arrangement. Personal eye and ear protection must be worn to care for the taken avoid of the possible injury when performing any of the working device or any other component of the part. When performing the work with a high temperature is involved, we use insulated gloves. To prevent receiving electrical shock when performing electrical tests, hands must be clear of the electrical components, contacts, housings, and required for the in-lab grounding procedure must be strictly adhered to, and a wooden workbench dimension should be used. Failure to heed this warning could result in severe injury or death. An adequate support for the lift device must be able to support the complete unit with the major component during the removal, the installation, maintenance of the procedure. Observe the weight information stay throughout the repair of the procedure. 8.0. 8.0 Cleaning solvent lubricate. Cleaning solvent. The solvent used to clean specified reusable metal parts must be an alphalytic organic solution, such as a mineral spirits that dissolve the oil that will dissolve oil, grease, and will permit the parts to be cleaned without abrasion. The lubrication note: the following lubrications are required when working with a 3 CWDL on loop compressor. The number 2 silicone grease, Wabtec Corporation specification M76801. 76802. Compressor oil, heavy duty compressor for the variation of ambient temperatures below 10 degrees Fahrenheit. Below 10 plus 10 degrees Fahrenheit. The ATMS viscosity grade number SUS at 10 degrees Fahrenheit equal to 215. Wabtec Corporation specification M7611520. The oil shall be highly quality solvent, refined paraffin base with a suitable blend. The adhesive to inhibit the forming rust, oxidation, wear, and required detergents are not permissible. Anti-wear additives are recommended. Or the compressor oil, heavy duty compressor for the operation above the ambient temperature above 10 degrees Fahrenheit. ASTM viscosity grade SUS at 10 degrees Fahrenheit. 315. The Wabtec Corporation specification M761620. The oil should have high quality solvent, refined paraffin based suitable blend. Additives inhibit rust for oxidation, wearing, and required detergents are not permissible. Anti-wears are additives are recommended. Compressor of the oil, heavy duty compressor for the high ambient temperature operation above the 120 degrees Fahrenheit. ASTM viscosity grade SUS at 100 degrees Fahrenheit. 465. Wabtec Corporation specification M7617. The oil should have the high quality solvent, refined paraffin based suitable blend. Additives inhibited the forming of the foaming, rusting, oxidation, wear, and equipment detergents are not permissible. Anti-wear additives are recommended. Mixing compressor oil grades or manufacturers to be avoided. Ferrocite number 338. Lock nut in lubrication is equivalent. Alright, 9.0 part catalogs and replacement parts. Part catalogs. Current part catalogs for the 3CWL compressor may be obtained with the Wabtec Corporation representative by writing Wabtec Corporation, Wabtec Locomotive Products, 1001 A or Brake Avenue, Wilmington, Pennsylvania, 15414800001 USA. The part number, the description, particularly with the compressor, must be finished with the requesting with the parts catalog of the compressor part and the number that is typically found with the stencil nameplate with the attached for the compressor case. The content of the part catalogs are subject to change and the responsibility of the owner compressor to obtain the current parts complete catalog. Alright, important. To obtain satisfactory operation of the 3CWL compressor only with the replacement parts that are supplied with the parts with the recommended with the writing of the Wabtec Corporation or to be used with the maintenance of the particular device. The replacement part number that is used for the publication covers the parts that are available at the Wabtec Corporation. When ordering replacement parts, give the part number and descriptive part name to be sure that the desired part is ordered. Consult with the Wabtec Corporation representative if any additional information is required for the replacement part. Part catalogs are available at the Wabtec website, techinfo.wabtec.com. Going directly to the technical info page. 393 Tools and Fixtures. Several drawings includes publication covering the tools and fixture that may be made over other facilities. Proper removal of the installation details. Wabtec Corporation assumes no responsibility for construction and use of those tools. The fixtures should not be held liable for bodily injuries and equipment damages. Alright, 10. Maintenance schedule. Warning: it is recommended the procedure lift of the maintenance schedule be performed at least once during the specified time period, more than frequently in the surface conditions, so indicate the failure to perform the procedure specified time period may result in the damaged equipment, which could possibly cause the malfunction, but may result in properly damage or bodily injury. Sort of maintenance roles may be necessary depending on the severity of the surface use of the compressor with the subject is the user responsibility to determine if the more frequent schedules of maintenance are required. Every 3 minutes, check the crankcase oil, and if necessary, add oil. Check oil pressure necessary. Remove the shim washer to achieve the desired pressure. Replace the oil relief valve assembly. If the oil pressure cannot be corrected, provide the removal of the oil shim every 6 months. Figure 6, item 3. Every 6 months, check the operation of the unloader, check the exterior intercooler assembly clean, inspect the removal and blow clean, and if necessary, replace with the compressor intake filters. Every 12 months, check and change the crankcase oil with the reference fit section 8 with the clean the interior crankcase. Use the natural sponge with the mineral spirits after cleaning with the dry crankcase complete. Replace the oil filter, clean the oil pump strainer with the place the necessary part number 653722. Replace the complete compressor air intake filters. Alright, every 24 minutes, replace and overhaul the discharge valve parts, discharge valves, and replace the overhaul air inlet, all the inlet valves, high and low pressure, the life of the inlet valve depending on the severity of the service available, the cooling oil passing rate with the compressor efficiency, the inlet air filtration, 2 year for the valve change, the periodic recommended with the Wabtec Corporation. Individual operating conditions will have the strong influence on the valve's life. Clean inspection under load mechanism, replace the crankcase breather valve. Every 36 months, clean an inspector under the mechanism, renew the valves. At least once every 4 years, 48 months, 4-year overhaul period recommended for the compressor. Important for overhaul period represents the time of the period between overhaul recommended with the Wabtec Corporation actual time of the compressor for the operation service before being overhauled and performed with the heavy influences type of the service the compressor used and the mileage locomotive between the overhauls, ambient temperature of the compressor operates with the running of the speed of the compressor, oil change period with the environmental condition, inlet air and filtration. Actual time periods between the overhauls must be established by the user. Should be based on the user's condition experience. The compressor is removed from the locomotive for the regular overhaul, utilizing genuine Wabtec replacement parts. 11.0 maintenance procedures. On-car maintenance. During some of the following procedures component for the baby may be very hot. Proper procedures should be taken to prevent burns or other bodily injury. Check the oil level. Locate all the oil level gauge and dipstick. Oil level dipstick gauge is located within the opposite side of the spinner oil filter. If the oil level gauge is float type gauge, the oil level can be read directly on the float gauge. If the oil level gauge is the dipstick type, the oil level must be checked by removing the dipstick and reading the oil level measured on the dipstick. Either method can be checked with the compressor is running the drain condensated with the intercooler. Locate the intercooler draining valve. The drain valve is located on the bottom of the intercooler assembly. Carefully open the drain valve and allow any of the condensate of the drain to drain from the the intercooler. Once the condensate with the drain closed with the drain valve, change the oil compressor's crankcase. Oil may be very hot if the compressor was recently running. Locate the oil filter cap and nut. Remove. Locate the drain plug on the crankcase. Drain the plug is located between the main bearing plate. Remove the drain plug and allow the crankcase oil to drain into a suitable drain pan. Remove the small side of the cover of the crankcase. Allow access to the oil pump strainer. Clean the oil pump screen. Locate the screen assembly to remove the 5/16" bolt and washer. Remove the oil screen gasket. Clean the oil screen assembly with using mineral spirits and lint-free cloth. Use mineral spirits and lint-free cloth. Clean with the interior of the crankcase. Unapproved rags, proper paper towels, or other loose material should not be used. The cleaning of the interior crankcase. The lint and debris that can be left in crankcase. Any lift of the debris for the lift in the crankcase cause the clogging of the oil passage eventually damage to the compressor. Apply a new gasket, reinstall the screen assembly hardware, and reinstall the oil drain plug. Reinstall the side of the cover. Use the new side cover of the gasket. Remove the spin oil filter and discard. Apply the light coating of the oil rubber to the seal on the seal new spin oil filter. Install the new oil filter, refill the crankcase, approve the oil filter, approve the oil through the oil filter, reinstall the oil filter cabinet, remove inspector and replace the discharge valve, remove the discharge of the valve cover in the gasket, remove the discharge from the valve to the seat gasket located on the discharge valve, inspect the valve gasket or any of the damage excessive of the carbon building, repair, cleaning with replacing any parts that are needed. Reinstall the discharge valve with the reverse order, remove the inspector, replace inlet valve, remove the inlet over the clamp gasket. Remove the inlet valve of the valve seat gasket located under the inlet valve and inspect the valve of the gasket and for any damage excessive with carbon buildup. Repair and clean and replace any parts as needed. Reinstall inlet valve of the reverse order 11-2. Warning, 11.2, removal from the locomotive of lifting support mechanism cable to safety handling with 3,000 pounds is to be used with the compressing of the removal of the applied locomotive hand brake and the parking brake. All power with the compressor is to be cut off when the wheel chokes are to be applied with the wheels to prevent the vehicle from movement. The warning placards are to be placed on and about the vehicle indicating the work is being performed. Warning, allow the compressor to cool ambient temperature to minimize the risk of personal injury. Disconnect the compressor and crankshaft with coupling with auxiliary device that may inhibit the removal of the air compressor. Warning, may certain that all the air pressure has been vented with the compressor and the intercooler, all associated with the proper cup. Continuing, disconnect the underloader piping and the compressor discharge vacuum lines for the compressor. Drain the oil with the compressor crankcase to drain the cooling water from the compressor cylinders and intercooler. Remove the compressor from the locomotive, allowing the builder with the operating instruction that it is advisable to leave the mounting base of the shims in their respective position, preferably by wiring them in the place of the same compressor, but is to be reinstalled with the same locomotive with which is to be removed. This will aid considerably in properly aligning the machine as well as saving consideration, time, and effort. Transport the removed compressor to shop area for the maintenance. The transportation mechanism may be able to support 3,000 pounds. Installation and overhauled replacement compressor should be done with the reverse order of removal, following locomotive builder, owner, and operator instruction. Remove all the warning placards, wheel chokes, and before attempting to move the locomotive. 11.3, component disassembly. Component disassembly. The figures throughout the publication are of the illustrated purpose of the actual components may be slightly from these shown. During the disassembly process, discard all the gasket, counter pins, lock nuts, lock wires removed from the compressor. The external surface of the unit must be thoroughly cleaned before disassembly under low pressure for the jet and clean dried air on the below surface clean. Warning, protective clothing, including eye protection, should be worn during the cleaning of the compressor. The crankshaft coupling to avoid damage with the crankshaft with the club bearings, accessing care of the while removing the installing the current crankshaft coupling. Half of the couplings have the string fit with the shaft. The quicking heave of the coupling while the use of the gear plug will aid with the removal of the hydraulic removal feature that's incorporated with the shaft coupling is to be used to remove the coupling drive key. If they use the external details, move the intercooler, intake filters, underloader tubing, crank crankcase breather inside. Important, the compressor is equipped with the oil level flow gauge. Remove the gauge before removing the slide cover to prevent damage for the flow lever. One-third cylinder assemblage. Remove the hex head cap screws with each of the cylinder head. Remove the head of each of the cylinder. Remove the cylinder head gaskets and discard. Important. During the assembly, location involved removing the component of the piston, wrist pin, and connection rod bearing. Half of the connection rod cap associated with the cylinder of the compressor should be recorded as recommended, but these components be returned for the original position during the assembly. 11.3.6. Remove the hex head cap screw at the base of each of the cylinder. Remove each of the cylinder from the crankcase. Important, express care that the piston assembly does not fall against the rod. 11.3.7. Then remove it and scrap all the gaskets. Important, when removing the various gasket, care must be taken so not to damage the main machine metals. No wire brushes. The grinder tools are to be used when removing the gasket. Proper care for the use of the putty knife and the air chisel is permissible. Appropriate procedure within accordance with the instruction from the over maintainer. The compressor are followed and disposed of the gasket material removed during the tear down. 11.3.8. Remove the connection rod cap. Remove the connection rod with the piston assembly. Connect the rod with the caps associated with the connection rod to work together as a match to the set parts with the connecting rod with the caps and their mating connection rod at all times. Remove the piston connection rod. Scrap the rings. Crankcase disassembly. Remove the oil pump assembly gasket from the interior of the gasket. And the following procedure must be strictly adhered to in order to prevent damage for the main bearings. And so that go undetected can cause the short compressor life can result in the spontaneous machine failure that could result in bodily injury. Remove the crankshaft with the key with the end of the crankshaft. Remove the oil seal housing with the following with a manual drill for 125,000 inch diameter holes on the outside of the shield of the oil seal. Insert the floor seal, self-tapping metal screws. They shield, then use the screws and then gripping the points and pry out the seal. Certain type of nails and pullers have been found satisfactory for the purpose. Scrap the oil seal. Remove the retaining ring. Remove the retaining ring and oil introducing ring from the bearing plate. Remove the axe head cap screw for the screw of the bearing plate with the cut to the crankcase. Replace with the crankcase so the axis for the crankshaft is vertical with the main bearing plate is facing upward. Remove the hex head cap screw with the screw in the main bearing plate to the crankcase. Remove the crankshaft. The lifting mechanism capable of safely handling a minimum of 400 pounds to be used for the crankshaft removal and installation. Cylinder heads, inlet valve removal, inlet valve cover or clamp, and gaskets. Remove the inlet valve of the valve gaskets located under the inlet valve of the discharge valve. Then remove the discharge valve, cover the gaskets. Remove all the discharge valve seat with the gaskets located on the discharge valve. Oil pump pressure. Remove the oil pump screen assembly figure 510 with the oil pump figure 51. Move the oil pump figure 56 from the oil pump body 511. Oil pressure relief valve. Carefully remove the pressure adjusting cap figure 62 and the shim 63 for the oil relief valve body 61. Warning: care must be exercised when removing the pressure adjusting cap of the content of the valve assembly with the spring spring loaded. Remove the spring and the pressure relief valve, figure 64 and 65, 12, cleaning. Clean all the serviceable metal parts to facilitate inspection after the parts have been cleaned. Must be completely dried. A low pressure jet of the clean and dry air to blow the parts dry. Make certain the drilled oil pressure connection rod crankshaft are clean with the free of obstructions. Warning: important. All gaskets or rubber parts, self-locking hardware cotter pins are to be scraped off. Only the new Wabtec Corporation parts are to be used replaced with the scrap parts during the assembly procedure to permit the best fits and procedure. Spring may be wired to assist with the removal of dirt and scaly deposits. 13.0 condemning limits. Reference Table 1. Table 1 includes the minimum and maximum condemning limits applied with all main wear bearings for the CWDL compressor. Important: the dimensions given in Table 1 are based on the use of the parts supplied from the Wabtec Corporation. Alright, 14.0 repair cylinders. To replace any cylinder that is found with damage beyond the repair, all reusable cylinders should be refinished with the primary, preferably honing to eliminate the irregularities of the cylinder wall. The finish for the cylinder walls are after finishing them must be at least 25 to 40 micro inches. The crosshatch home marks should be 25 to 35 degrees horizontal, both with low pressure and high pressure cylinders. If the cylinder is not within the specified Table 1 of the cylinder remanufacturer, consult the Wabtec Corporation representative for the information from manufacturing the cylinder. Also, mounting the flange for the cylinder must be perpendicular with a bore of 2,000ths of an inch. TIR, total indicator reading, is determined with the dial indicator reading. It is mounted flange safe for the perpendicular may be the correct removing the least possible amount of metal from the facing of the flange while maintaining the same setting which the cylinder was bored. Minimum cylinder length specified in Table 1. Alright, 4.2 piston. If the piston is broken, contains excessive scuff marks and falls outside of the condemning limits shown in Table 1, replace the piston. Minor scuff with the scratches can be smoothed and rounded out of the file. Low pressure pistons. The low pressure pistons have the removal of the bushings and replace them warm. Replace old bushings with a new bushing. Replace the bushing required for each of the bushing. Either bushing to be cooled with the liquid nitrogen dropped into the piston. Room temperature cooling bushing with a dry ice and heated position and heat the piston to 200 degrees to 300 degrees Fahrenheit. High pressure pistons. The high pressure piston has a removable roller bearing. They are held in place with the retaining rings and before removing the bearing support the piston on the bearing removal. See figure 10. Use 2.5 and 1/32 of an inch diameter driving tool to remove the old roller bearings. Alright, starting with the bearing removal fixture, anvil, thrust plate, inner retaining ring, roller bearing driving tool. 14.3 piston rings. During any of the major overhaul repair, new piston rings are to be installed. Using suitable piston rings installation tool. New standard rings are high pressure compression, high pressure oil, low compression, low pressure oil. The ring should be expanded just enough to clear the piston. The care must be exercised to install the piston ring to prevent the damage to distortion. The position of the piston ring shown in Figure 11. Consult with the Wabtec Corporation representative for the information on the correct piston ring specific application. 14.3.3. When the piston rings have been properly installed, measure for the ring side clearance with using the appropriate feeler gauge, not the side clearance within which for the specified limits. If the side clearance is beyond the specified limits, successful oil passage may occur. 14.3.4. Using the appropriate field gauge, measure the gap of each of the piston ring with the measurement and width of the specified limits. If the piston ring gap is beyond the specified limit, the piston seizure cylinder scoring may result. Important: make certain that the piston ring gaps are not in line with the may cause excessive oil passage damage. 14.4. The crankcase. Replace the crankcase if cracked or broken, otherwise damaged or beyond repair. If the main bearings bore is eccentric worn more than 2,000ths of an inch, they may be rebrushed using the repair bushing. The consult with the Wabtec Corporation representative information replacing bushing. 14.5. Main bearing end plate. The replace of the main bearing end plate with cracked, broken, exceed the condemning limits is established in Table 1, otherwise damaged beyond the repair. 14.6. Main bearing cover plate. Then replacing the main bearing cover plate is cracked and exceeding the condemning limits established in Table 1, otherwise damaged beyond repair. Alright, this shows your Piston ring identification instruction. The notch type 1 shows the notch type compression rings and to be assembled in the piston with a notch toward the bottom of the piston. This one shows a ventilated double wiper taper face oil ring to be assembled in the piston with the taper edges. So here is your ring gap clearance for the high pressure, low pressure, or high pressure, or low pressure oil rings and compression rings at 200ths of an inch and 2500ths of an inch. Your ring side clearance, high pressure, low pressure, low pressure oil ring, high pressure oil ring. Shows the 44 thousandths of an inch, 51 thousandths of an inch, 44 thousandths of an inch high pressure oil ring, and your shows the low pressure piston with the compression rings and oil rings, and then high pressure piston with the compression rings, and then the oil rings. Alright, crankshaft, 14.7. The replace of the crankshaft accurately complete. Check the reveal for the following defects. Bent not more than 2,000 of an inch maximum or crank pin is condemning limit of the beyond, but the condemning limit is limited. Listed in Table 1. Measuring bearing of the jump 1 less than condemning limits of the listed in Table 1. Tap the threads and damage the extent of not being suitable for the reconditioned key weight pad. Damage beyond repair. The crankshaft should be checked with alignment of the valve to make sure the center hole is located at the end for the crankshaft to clean and true. Place the crankshaft cleaning device similar to the one shown in Figure 12. Make sure the crankshaft is running true. Check the crankshaft with the proper alignment. If the requirements are not met, the crankshaft must be replaced during the major overhaul. Allow the crew always replace the main bearings using new Wabtec main bearings from part number 592272. This shows the crankshaft undersized dimension alignment specifications. Alright, so you got your specification alignment of the crankshaft. 4.8 Connection rod. The connection rod must be visually inspected before removing and inserting bearing with the connection rod bushing. With a satisfactory alignment with the connection rod will be reflective of the water pattern. The water patterns look straight across the bearings. No further action required. Produce the checking alignment with the connection rod. If during the visual inspection used to insert the bearings to reveal the uneven wear pattern, check the alignment. With the piston removed, the connection rod with the insert of the wrist pin with the connection rod at the wrist pin. Insert with a similar diameter pin with the correct size within width the crank pin with the connection rod. Tighten the connection rod cap securely with a pin with 100 to 150 foot-pounds of torque for the crank castle nuts. Place the crank pin with the connection rod between the V block with the flat check with the surface shown Figure 13 with the connection rod perpendicular to the check valve. Checking surface the checking distance from the checking surface to the highest point with the both ends with the wristing pin. The check should be made with a dial indicating the reading with the checking surface at both ends with the wrist pin must be within 1,000th of an inch over every 6 inches length of the wrist pin. Turn the wrist pin end of the crank connection rod downward until the connection rod is horizontal with the checking surface of the connection rod within the position with the checking distance. Checking surface to the highest point, both ends of the wrist pin. Check that should be made with the dial indicator the reading with the checking. The surface of both the ends of the wristing pin must be 1,000th of an inch or every 6 inches for the length of the wrist pin. Or your connection rod crank pin fit. The fitting of the connection rod with the crank pin is designed to insert the bearings made with the specification Wabtec Corporation. Also view the new insert bearing for the wear adjustment crank pin that is filled with oil before the placing of the connection rod and cap in place. Also, the new inserting bearing of the connection rod must be filled with the bolt castle nut and cotter pin which are available with the Wabtec Corporation. The torquing method is to torque the castle nuts every 100 foot-pounds, and that the continuing torque nuts until the new cotter pin can be inserted through the slot in the nuts and drill holes in the bolts. Or your connection Figure 13 shows the connection rod arrangement with the checking alignment, the block and the V block, checking surface holding pin and measuring pin. Your oil pump. Prior to disassembly the oil pump's inspection exterior of the pump, if there's any sign of wearing damage, remove the oil pump. Figure 15.56 the oil pump body. Check the oil pump drive gear. Figure 5.9 end plate should be between 1,000 and 4,000 of an inch. Adjust lock and if it's check the oil pump. The oil pump drive with the gear with the interface of the key with the slot with the excess wear of the damage replaced if necessary. 1410 oil level gauge. The oil level gauge float type. The oil level gauge must be inspected to determine whether it is working properly. Replace the complete with the assembly worn, broken, or inoperative. The new oil level gauge dipstick can be used with the replacement of float type oil level gauge without modification of the compressor crankcase. So with the Wabtec Corporation representative ordering specific information concerning the oil level gauge dipstick. 411. The main bearings. The main bearings must be washed with alphatic solvents, mineral spirits, completely dried and boiling is low with the pressure clean dry, and examined carefully with a warm pit damage. Otherwise, serviceable bearings must be replaced. If there is any question of whether the bearing is serviceable or not, is to be replaced. The careful examination reveals the bearing is serviceable condition of the bearing is lubricated with oil. Immediately after the examination, wrapped in vital corrosion inhibitor of the VC1 paper. 412. The cylinder heads and valve. The cylinder heads. All cylinder heads can be reused, provided if they are not damaged, cracked, or cut, broken, excessive, worn, damaged in any way. The head is to be if the head is to be scrapped and replaced with a new Wabtec Corporation part. Use the caustic type of the cleaner or the suitable cleaning solution capable of removing the attached carbon. Use the caustic type cleaner with the other suitable cleaning solution capable of removing the attached carbon. After the cleaning cylinder heads have been cleaned, they must be dried completely using low pressure jet clean with a dry air blow to the cylinder head dry. Valve seats must be visually inspected for nicks and cracks. Valve parts successfully put. Valve gaskets may be reused. There is serviceable condition that had been adequately repaired. 413 unloader. 413.1 after assembling the cleaning unloader valve with the parts of mineral spirits, drying the completely blowing the jet clean the dry air, inspect the unloader valve seats for any nicks groove that can affect the sealing of the surface. Alright, this shows your unloader valve assembly. Alright. 14.4 intercooler. The new gasket should be used in the reassembling intercooler disassembly side plate for the main body of the intercooler. Remove the scrap of all the gas clean the intercooler inside of the outside using the inhibited air alkaline cleaner with the solvent and water to remove any outlet oil film accumulated there through the flushing of the with hot water and blow dry. Testing the intercooler with assembly to verify that not any leaks attaching the testing fitting blanket with a pad with apply 50 psi air pressure testing fitting test fitting and submerged air assembly into the water tank. Alright, 14.15 safety valve. The safety valve used for the intercooler must be tested in accordance with the following Wabtec Corporation testing specification. A1 intercooler relief valve setting of the 65 psi gauge Wabtec Corporation test specification T26250. 416 crankcase breather. The metallic filter in the crankcase breather must be replaced to avoid disintegration due to fatigue. The breather valve diaphragm must also be replaced. All the breather parts must be replaced if necessary. Alright, 14.7. Your torque value. The following torque limits are recommended to tighten the nuts and bolts of the compressor. Your 5/8 of an inch bolt is 90 foot-pounds, and the half-inch bolts are 50 foot-pounds, 3/8 of an inch, 20 foot-pounds, 5/16 of an inch, 11 foot-pounds, 1/4 inch, 5.5 foot, 5.5 pounds. Connection rod castle nuts 100 to 150 pounds. Coupling nuts 500 pounds. 15.0 assembly, and I'm going to cut the tape.